Hello, it is Scott Balicki again, and I am going to tell you about Unit 3 in Living by Chemistry entitled Weather. Now, keep in mind that in terms of the pacing guide for the Boston Public Schools, it is recommended that you teach Weather Unit 3 after Toxins Unit 4, and that also has a fire interlude within it. But I will be referring to weather as Unit 3 because that is the way that it is described in the curriculum. However, it should be taught after toxins, not before. That having been said, in this screencast, I'm going to give you an overview of the weather unit, talk about 3 difficult lessons, and provide you with a couple of basic resources that you can use. So, weather is not one of the longer units in Living by Chemistry. It's 19 lessons, which are divided up into 3 sections. Section 1, physically changing matter, which deals with temperature scale and a little bit about the properties of liquids versus gases. And Section 2, which is pressing matter, deals with changes that can be made primarily to gases, either in transitioning from a solid to a gas or changing the temperature versus the volume versus the pressure. And then in Section 3, concentrating matter is when we talk about the idea of how changing the number of particles changes gas properties. So to go through the lessons themselves, in the first section, we begin with our hook into the unit where we talk about weather science and the sorts of things that could be measured and how they could be related to the weather. In Lesson 2, students take measurements relating height and volume of rainfall and learn why rain gauges have to have uniform sides. This in of itself helps introduce students to the ways to design a graph, which is very important because there's a lot of graphing in the weather unit. In Lesson 3, we compare the density of liquids and solids. Again, another means to use graphs in order to make inferences and conclusions. Then students build their own thermometers. I'll discuss about Lesson 4 in more detail as one of the more difficult lessons. In Lesson 5, students learn why scientists tend to measure gas temperature in terms of kelvins rather than in terms of degrees Fahrenheit or Celsius, because it is an absolute scale. Lesson 6, students are introduced to Charles' law. They see a couple of demonstrations and then perform some calculations and some graph work. And then front and center, students learn about fronts, moving air masses, and how they relate to weather. In Section 2, we begin with It's Sublime, which deals with gas density. Students get to do a cool experiment using dry ice. In Lesson 9, students observe and process some demonstrations involving changes to gas pressure. And in Lesson 10, students carry out an experiment where they themselves can deduce the relationship between pressure and volume of a sample of gas whose temperature doesn't change. In Lesson 11, students are introduced to Gay-Lussac's law via a demonstration. And in Lesson 12, students use a PhET simulation in order to learn about a molecular view of pressure. In Lesson 13, students learn about the combined gas law. And in Lesson 14, students do an experiment in which they make a cloud in the bottle and see what the relationship between phase, pressure, temperature, and volume is for an enclosed sample of gas inside that bottle. When we look at Section 3, there are a couple of lessons where students are introduced to the N in the ideal gas law and learning about numbers of particles in Lesson 15 and 16. In Lesson 17, they learn about the volume of air in their breath, a practical application of the ideal gas law. In Lesson 18, students use a wet bulb and dry bulb thermometer in order to calculate the relative humidity. And in Lesson 19, students learn about hurricanes. So, difficult lesson number 1. that I want to discuss is actually lesson 4, which is where students make their own thermometer. As long as it's done correctly, this is something that I think is a very good lesson for students to learn about how temperature scales were developed by scientists in the first place. But if you can see this picture here that I'm circling, the bottle would actually have to be full. Okay, so this was just the best picture I could find on the internet in order to illustrate the idea that right here, this needs to be dry where the stopper is added to the bottle. Whereas here, where the straw is going through the one-hole stopper, it's very important that it be lubricated with Vaseline or vacuum grease in order to ensure that there's no leakage. Then, when students are doing their zero temperature in a cold water bath, they should do that first. All right, and just recognize that the difference between room temperature and zero is going to be much smaller. So you want to mark the starting point of room temperature and then the cold temperature with a very fine point Sharpie or marker, and then transfer it to the hot water bath. This is something that it would be good to try a couple of times yourself so that you can know where the starting water line should be in order to be close enough to the bottom so that it has more room to expand towards the top, towards what we call 100 degrees Celsius, but not so close to the bottom that it goes below what we can see in the straw. Difficult lesson number 2 is it's sublime. You need dry ice for that. So I buy it at Brookline Ice and Coal, which is near my school, Boston Latin School. Be aware that you're probably going to need to buy it in a certain increment. I believe 5 pounds was about $11 last year. You can buy it the night before. If you do so, you should pack it with towels in a cooler, and then it will stay overnight for the lesson the next day. But then if you're using it for a lesson, it's not something that's good for a whole week. And I would recommend a variety of different bags and volume measuring containers. You can draw lines on a bucket, like those $5 handyman buckets that can be purchased at Home Depot. Those are good for collecting approximately a molar volume of gas, approximately 22.4 liters. So that's a good visual for students to have as it comes up later in the unit as another example of students learning about counting units with gases. Feeling under pressure, lesson 10, is the third difficult lesson. You need bathroom scales. This is something where physics teachers may have those. That may be something that you can borrow from them. And then you're going to be using syringes. Now, this syringe in the picture here, you can see the tip. This tip will bend and break if students push too hard. And students tend to get pretty muscly when they're trying to push the weight as far as they possibly can. So be aware that if your syringes have tips like this, you need to instruct students not to go crazy and not to push too hard. And these tips can be sealed off with either hot glue gun and duct tape, or you can actually purchase lure locks, which will completely seal it off. Either way, the tip would still be somewhat flexible. So if you don't have a flat tipped syringe, just be aware that students will need to be careful. But this experiment does a good job of enabling students to themselves derive the relationship between pressure and volume. So for resources, go to my useful links page of my class website, and you will see some alternative designs that I've put forth for lessons. I think they're pretty self-explanatory. I did a lot of things with spreadsheets and Google Sheets. You're welcome to use. You can find those there. And also many things with simulations from the PhET website. And as always, check your pacing guides, student learning objectives, and calendar from the BPS Science Weebly. If you need to contact anyone with questions, or if you need help, Pam Pelletier, Holly Rosa, and myself, we are always available if you would like to email.